Hey, welcome back to ClearSpot. We'll break down the science, the real-world case studies, the hard numbers from utility-scale plants, and the industry forces that are making bifacial panels the default choice for the future. This isn't theory. This isn't wishful thinking. This is the technology that experts believe will make up 70% of the solar market by 2030. So sit tight, because by the end of this video, you'll understand exactly why bifacial panels are more than just a smart upgrade. They're the future of how we capture the sun's power. Let's start with the basics. For decades, solar panels have been monofacial. That means they capture sunlight from just one side, the top. It works, but it's inherently wasteful. Think about it, light is bouncing all around us, off the ground, off buildings, off surfaces, and a monofacial panel ignores all of it. Now imagine if we could collect both sides of that light, the direct sunlight hitting the top and the reflected ambient or scattered light hitting the bottom. That's exactly what bifacial panels do. Here's how it works. Bifacial modules use solar cells on both sides of the panel, sealed between transparent materials, typically glass or glass with a transparent backsheet. The front side captures the direct sunlight, just like a normal panel. The rear side captures what's called albedo light, the reflected radiation from the ground, nearby structures, or even diffuse scattering in the atmosphere. And this isn't a small effect. Different surfaces reflect very different amounts of light. Black asphalt reflects about 12%, grass reflects around 26%, desert sand reflects about 35%, white concrete reflects nearly 50%, and snow, fresh, untouched snow, reflects up to 90% of incoming sunlight. That's like putting a giant mirror under your solar panels in winter. By capturing this reflected light, bifacial panels can generate anywhere from 10% to 25% more energy than monofacial panels in the same location. This is the kind of improvement engineers dream about. More energy from the same footprint, the same hardware, the same land. It's not a small incremental gain, it's transformational. All right, theory is nice, but let's talk real-world numbers. What happens when you actually install bifacial panels at scale? Take the UK's largest bifacial solar plant, located in North Yorkshire. Researchers conducted a 4-year study on this 34.7 megawatt installation with over 91,000 panels. They set up a direct comparison, bifacial panels versus monofacial panels under the exact same conditions. The results were striking. Bifacial panels delivered an average 15.1 to 17.3% more power. The gain was consistent across all 4 years, even accounting for natural degradation of the modules. Think about that year after year, through rain, winter, cloudy skies, and long summer days, bifacial panels just kept outperforming. Now let's cross the Atlantic to the United States. In Nebraska, Bluestem Energy Solutions decided to test bifacial versus monofacial in a real-world utility setting. They built 2 nearly identical solar farms, same capacity, same design, just 48 miles apart to keep weather consistent. Site 1 had monofacial panels, while Site 2 had bifacial panels. After just 7 months of operation, the bifacial site produced 5.5% more electricity. Even more importantly, the electricity was worth more because bifacial panels produced more during high-demand hours. Their power fetched $30 to $49 per megawatt hour, compared to $23 to $46 for monofacial. So the panels weren't just generating more, they were generating more valuable energy. In Nevada, a solar farm ran a head-to-head test, bifacial panels versus traditional ones. The result? A whopping 15% more energy output from the bifacial system. Proof that under the right conditions, the boost can be massive. And this wasn't just because of technology, it was because of the environment. Nevada's desert sand reflects a lot of light, creating the perfect albedo effect for bifacial panels. And it's not just isolated projects. All around the world, studies keep showing the same pattern. In Palestine, bifacial systems produce 6.8% more electricity on average. Vertical bifacial installations showed an 11.4% boost in daily output. On reflective rooftops in commercial projects, gains of 22% have been reported. These are not small margins. In the razor-thin economics of utility-scale solar, these improvements change the math completely. So if bifacial panels are so good, why isn't everything bifacial already? The answer, as always, comes down to economics. The global bifacial solar panel market was worth about $15 billion in 2025. By 2033, it's expected to hit $60 billion. That's a growth rate of about 18% per year, far faster than the broader solar industry. Why? Because the economics just make sense. Take the Nebraska case again. The extra cost for bifacial panels was about $10,000 per megawatt. That's not small, but the added production and higher demand value paid it back in under 2.5 years. For residential installations, studies show payback periods of just 3.4 years in favorable conditions. After that, it's pure upside. One commercial solar project in Arizona reported an 18% reduction in the levelized cost of electricity. Basically, that's the true cost per unit of energy over the system's life. Why? Well, because the same installation now produced significantly more electricity, spreading the fixed costs across more kilowatt hours. In the United States, there's another hidden advantage. Bifacial panels are exempt from Section 201 tariffs, a 14 to 14.75% tax on imported solar modules. This exemption, extended through 2026, makes bifacial panels immediately more competitive. And, durability really matters. Field tests in Minnesota showed bifacial panels degraded about 5% less over time compared to monofacial ones. That means their performance holds up longer, boosting lifetime returns. But the benefits of bifacial go beyond money. They also deliver environmental and practical installation advantages. First, land use efficiency. By generating more electricity from the same footprint, bifacial panels reduce the land area needed for solar farms. In Germany, researchers calculated that using bifacials could reduce lifetime emissions by an additional 7% compared to conventional solar farms. And the design flexibility is a game changer. Vertical installations are ideal for agrivoltaics. Farms can grow crops while panels capture light from both sides. Vertical systems also provide unique output patterns, peaking multiple times per day. Parking lot canopies. Bifacials shine here, literally capturing light reflected off cars and pavement. Building integration is another area where, on reflective rooftops, bifacials can capture up to 20 to 25% more power. And they're climate flexible. In snowy regions, reflectivity can hit 90%, making bifacials incredibly productive. In urban areas, light bouncing off buildings gives them a unique advantage. In deserts, sandy surfaces give a steady 30 to 35% albedo boost. In short, they're adaptable across environments. All of this adds up to a major transformation in the solar industry itself. Today, every Tier 1 manufacturer, Longi, J Solar, Trina Solar, is producing bifacial modules. Factories are being retooled and supply chains are shifting. In many cases, bifacials are now the default module type. Utility-scale adoption is really driving this shift. Large solar farms benefit most from the efficiency gains, and ground-mounted systems make rear-side capture easier. Tracking systems, as you might expect, are being optimized for bifacial use. And, technology improvements just keep coming. We're seeing higher efficiency cells, smarter mounting systems, and improved tracking algorithms. By the year 2025, global module demand is expected to hit somewhere between 650 and 700 gigawatts per year. And interestingly, bifacial panels are expected to capture the majority of that growth. Of course, no technology is perfect. Bifacial panels do face some challenges. They're still just a bit more expensive up front. Installations require careful design to really optimize things like tilt, height, and spacing. Plus, both sides have to be kept clean, which honestly raises maintenance needs in dusty regions. But these challenges are shrinking. Costs are falling as production scales up, installers are gaining more expertise. And now new systems are actually being purpose-built for bifacials. And as all that happens, the advantages will only grow. With global investment pouring in and performance data piling up, bifacials are really set to dominate the 2030s. The evidence is, overwhelming. From the UK's 34-megawatt plant showing 17% gains over 4 years, to Nebraska's bifacial project delivering higher value electricity, to Nevada's desert farm hitting 15% improvements, the verdict is clear. Bifacial solar panels aren't a gimmick. They're not a niche. They are the new standard. With the market expected to quadruple by 2033 and dominate by 2030, bifacials aren't just an upgrade, they're a revolution. So the next time you see a solar farm, ask yourself, are they capturing all the sunlight? or just half of it, because in the energy future we're building, that difference is everything. Like, share and subscribe for more solar insights. ClearSpot, smart device, smarter decisions.